We're recording now. Thank you.
Okay, I'm gonna share my screen too, which seems to be a good way to do this. Okay, and so so the story, the title of or the focus of tonight's ProRate Energy meeting today is July the 14th, which happens to be Bastille Day, so it's a good day to break out and say something and declare our freedom, which is what the French did a few hundred years ago.
Yes, indeed.
And so resetting the parameters of my inverter to handle lithium iron phosphate battery is a focus of tonight's meeting. So first of all, let me show you a picture, which I think you guys got to see. This is a view of a corner of my house on the ground level. Most of my living area is above. Downstairs is like a major warehouse. But in this one corner, you can see I'm pointing out to the inverter, and above it are the all the electrical connections needed to take a 110 output inverter and turn it to 220 source. This is the transformer here, a box. And then it goes from 110 to 220. And these 220 circuits are powered when the grid goes down. So I can simulate the grid going down by throwing a circuit breaker in this circuit, which then disconnects the power source to the house and turns on this, causes this automatic transfer switch to send current to my house. So it's AC, goes to my house in 220 on two 110 legs. And all this inverter does is it takes the AC electricity that's being fed into it when the grid doesn't go down and put it in batteries. So this whole system was set up in 2010 when there was a 80% tax credit for solar. Of course, most people in Louisiana are so, quote unquote, not literate that they didn't know that solar is not solar or batteries. But anyway, I got it passed through as a tax credit in Louisiana, even though it was no solar, all batteries. By the way, solar or batteries means solar or solar and batteries are just solar. And so based on that logic, I got an 80% tax credit. This system, not including this big black battery here, has been in my house since 2010. And these 4 batteries here, I had 4 more behind it. So they're each 12-volt batteries, so it's a 48-volt system. And it was quite a few kilowatt hours, 20 kilowatt hours are in these 8 batteries. However, there was a lead acid batteries. And lead acid batteries, even if they're deep cycle like these, can only do 700 cycles. And 700 cycles might be good for the next 5 or 10 hurricanes, but it's not getting you very far if you try cycling every day in the prorate way, namely with the time of use rate. But when these batteries were put in, I wasn't thinking about time of use rates. I was thinking about, I don't want to evacuate like I did 5 years ago for Hurricane Katrina. And no, Sharon, I did this in 2010.
Oh.
I'm talking about 5 years ago.
20 years ago.
If Sharon want to eavesdrop, you got to pay attention better, okay?
Years ago.
Okay,
Okay.
so.
Myron, you got to learn. A woman is always right. Come
That's
on.
right.
Myron doesn't learn that.
My wife tells me, happy life is a happy wife. Anyway, so behind this brown box is my DC panel. And right here is the circuit breaker that allows me to turn off the DC connection, both for charging and discharging from the inverter to the battery system. And this kept me going for about 10 or 15 years. And now it's time. This battery system is completely 100% shot. It's dead. And Sharon says, what are we going to do for the next power outage, which we're almost sure is coming this year. It's already slammed Texas and North Carolina, the storms. So they're probably coming to New Orleans. We better get ready.
There's something in the Gulf. That's
Yeah.
gonna develop, right?
So we bought this thing and it's hard to see. I'll see if I can zoom in a bit so you can see it better. It's called a big battery. See, I'm gonna zoom in a lot. It's going the wrong way. It's going this way. Okay. I don't know if you can see, but the name on this battery is a big battery. You can see that right here. And so that's the name of the company. And they sell this box, which was 100 pounds, which is as much as any one of these batteries weigh. And it's a lithium iron phosphate battery. So in order for this inverter to work with either of these sets of batteries, it has to be set up properly. Namely, the parameters have to charge just right and stop charging just right, or the batteries will fail from misuse by the inverter. So the chore was, first we got the battery recommended by the company who made the inverter. The inverter is made by Outback. And the battery was, they recommended a big battery, this specific big battery. Now the battery system in orange was a 20 kilowatt hour battery. Now it's a nothing battery, but it was originally 220 kilowatt hour battery. This battery alone is 5 kilowatt hours, a little bit more than 5, negligibly more. However, it's probably worth about half as much as all the batteries below it because of the way we use them. We get into that shortly. So, first I had to connect it. I did that. You can't really see the wires, but the wires are going through here, and they make it to the inverter. And then I had to tell the battery, I had to tell the inverter how to use it. So that's what we're going to be talking about. Okay, so going back up, let's see what screen resolution I'm at now. A little bit too low. Let me get a little higher. So
Hey, why didn't you call Outback?
I did call Outback. And Outback doesn't make batteries, and they recommended this battery. So I'm using the battery they recommended.
And they don't have any way to hook it up?
Oh, you hook it up, but the question is, Outback has a way to change the batteries. In fact, let me show you on the picture.
Yeah, I work with Outback systems.
This thing right here that I'm highlighting, this little white oval thing is called a mate, M-A-T-E. Not a checkmate, but it's the mate that allows you to communicate parameters to the inverter in case you want to change something. And that is what I had to learn how to do, not just learn how to access it and how to change it, but figure out what to change it to. And that was a quest I've been on for a week until I finally finished it on Friday. So, give you another way to look at the same thing. So what I had to do, are these words big enough now? You guys can see it on the screen? Or should I make
It could be a little bigger, but if you read it to us, that's okay. Well,
I'll make it bigger. I tend to read you too much, so, okay, all right, how's that? You can read that?
yeah.
Fine.
Okay, so my pressing chore this week was to connect the new battery where the previous batteries had died. So my home would have resilience during a hurricane. Remember, resilience means you got a lot, but not everything you used to have, so you can get through it. That's what resilience means. Reliability means you get all you used to have, but we're not going to get all we used to have because the power's up. So, and the reason why I had to do it is because I decided to take a trip to Colorado to take care of my mother, my 103-year-old mother, over half a year ago, because my brother needed relief because he was taking care of her all the time. And even though this jeopardized my wife's comfort during the height of the hurricane season. So challenge I faced was how to put in the parameters and which would cause the inverter to charge and discharge. But it had been doing lead acid batteries, which is what the orange batteries are. And now it has to go to lithium iron phosphate. Now, it's important to understand they don't have the same chemistry. So I don't want to give you a chemistry class or a chemistry physics class, but at least you should know that when a cell was created, one of the first cells were created, I don't know if that was Faraday or whoever created the first cell, or maybe his name is Amp or whatever it is. He created a cell and he noticed there was a voltage across it. And depending upon the various chemicals that he put in, first he put in some acid, then he put in one metal or another metal. In fact, the most common batteries we use are zinc copper batteries. The most common batteries we have in our flashlights until recently, they're copper zinc. And copper zinc at a certain acid solution creates a certain amount of voltage, maybe a quarter of a volt or half a vote or 2/3 of a vote or half a vote or one vote, whatever it is. And each one has a characteristic voltage corresponding to the electronegativity of the metal ions. And I remember in high school, I remember the most electron negative ions. It's lithium, potassium, sodium, aluminum, and so forth. Those are the most electronegative. And notice that lithium is at the top of the list and it's in the battery. Iron is also there, so it's really lithium ions and iron phosphate ions, and they mix together and they create a certain voltage. And by stacking these cells together, you get voltage high enough. So the battery is a 48 volt battery nominal. In lead acid batteries, we tend to stack them to 12 volts and then make them, excuse me, I have my super dog complaining again like he does every time. Okay, get out of here for good. Okay. Okay, so anyway, that's the chemistry. That tells you the voltage. It doesn't tell you all about battery. Batteries, when they charge and discharge, they tend to leave deposits inappropriately on one plate or another, and that's why they eventually degrade to uselessness. But it also tells you which voltages are good for the battery and which ones are bad. So to understand that, I want to point you to a key picture in here. So in the later at the end of this whole process, which was Friday, I started on Monday. I actually sent an email to Kay Aiken, and who is, our star new member of the board of ProRate, who lives in Maine. She's actually does battery manufacturing and as a business. And Jeff Canton, who's the head of the local solar company in New Orleans, and asked them to give me help. And in order for you to appreciate what kind of battery is, I move you over to this graph. So I'm going to move you to this graph, which is on page 18 of the published graph of the battery manual. So I'm going to the battery manual. Okay, this is the big battery manual. I don't know if the screen resolution is good. I hope I'm still at high resolution. Let's see. We got to a little higher resolution here. Okay, now I'm going to go to page 18, and you see this is page 1, page 2, 1, 2, okay, 3, 4, 5, 6, 7, 8, 9. You're getting there. Come on. Come on, let's go a little bit faster. Okay. And we'll see the graph shortly. So unfortunately, I couldn't link directly to the page in that email, so we've got to scroll down to it. And it's about to come up now. It's about to. So understanding, here is the graph. Now, this graph says, and I explained it's a voltage versus percentage of charge. So a battery is charged up to 100% and discharged down to 0, and there's a voltage corresponding to it. So we notice that when the voltage is up to 58 volts, it's 100% charge. When it gets down to, it's 99% charged at as little as 56 or 57 volts. We don't need to charge it past 56. And it stays pretty much the same amount of charge all the way down to around 20% around here. So at this point around the graph is like 20% charged, and over here is like 10% charged. And you notice the voltage at 20% charged and 10% charged is pretty big considering the small changes elsewhere. And so when you want your battery to charge in the green zone, it has many more cycles. If it gets into the red zone, it loses its life quickly. And in the lead acid battery case, it would be charging down past 50%, whereas these batteries can be charged down past 25% without really hurting them. So that's a big deal. So you get a lot of extra, all this extra area under the curve is energy that you can get out of the lithium ion battery that you can't get out of a lead acid battery. Also, the number of cycles is not like 700, it's like 6,000 or 7,000. So it's 10 times as many cycles and 15% is more energy per cycle. It's a very desirable battery, but you still have to keep it out of the red. You get it into the red, where you get into this area, you can really lose your battery. So how do we keep it in this area? So we're going back to the email that we're talking about. I needed to get the state of charge below 99% because that was a recommendation that I spoke to the people at Big Battery. Say keep it between 99% and 10 to 20% state of charge, because that'll give us the most energy without damaging the battery. So I just showed you, I'll go back to the graph again so you can remember. At voltages just under, say, 56, 57 volts, that's the maximum you want to get to make sure you never get over 99% charged. And you want to also recharge it when it gets too low in this zone. So you want to keep it running in this cycle to get more cycles. So how do we do that? We have to tell the state of charge should stay between 99% and 10 or 20% state of charge. The upper range is described by 57.6. That's the number that the battery manufacturer recommended. So I'm going to show you the battery manufacturer's charging sheet. So this is the battery manufacturer's charging sheet. I'm going to go to another page, and this is what they claim are all you need to know about setting the charging parameters. Again, I'll make it bigger so you can see it. And it's not that many lines in the chart. Only these 10 lines. They claim all you need to know about to set the charging parameters is on this graph. And you can see if you have questions, you can call them up. Well, because my battery is a 48-volt battery, you can ignore the first two columns. And basically what it says is that if you want to charge it, you want to charge it around 57 volts. And if you want to keep it from going too low, you need to restart charging at 50.8 volts. 50.8 volts, remind you where that is on the graph. 50.8 volts is right around here, okay? And that keeps you out in the yellow, but not far out of the green. So that's how they recommend it. And so that you can see how the charging, the graph and the spec sheet correspond. And so you want to keep it charged up to 57 volts and restart charging it when it gets down to around 50 volts. And you'll get the largest cycles. So with that information, I started trying to set the parameters. However, one of the first things I found, let me just go back to this. So I needed to tell, using the MAPE, remember that's the thing that you use to set the inverter. And I remember that's the oval thing on the wall. I needed to set it so that it would charge no higher than 57.6, because that would get me past 99% charged. And when it got really low, if I wanted to keep it charged down to 10%, I would use 50.8 volts, or if I wanted to stay up to 20%, I use 51.2 volts. And the tech told me that if I stayed above 50.2, I could get almost twice as many cycles than if I let it go down to 10%. However, if I use the 20% state of charge versus the 10% state of charge, I get less energy. I only go from 99% to 20, which is around 70 state of charge. If I went to, around 80, and if I did this, I get 90, so I would get significantly less, or the ratio of energy per cycle is 90% to 80%, okay? And therefore, I would lose energy per cycle, but get more cycles if I went to the 20% state of charge. I want to stop right now. See anyone not following what I'm talking about? Dave or Richard or Brendan, do you understand what I'm saying?
I'm certified to install those batteries.
So
Sure.
you,
Yeah.
you understand it, right, Dave?
Yeah.
Okay, do you
Yeah, it
understand?
makes
Ian?
sense. Yeah, everything you've described makes sense.
Right, okay, so I had to set it, and then I was fine, I put in all the parameters, in fact, I published the parameters to the big battery people. Early in this email, you can see that I sent it to support a big battery. And what did I send them? I sent them this set of choices. I said, let's use voltage is 48 volts, charge voltage is 57, volt voltage, all those numbers that you saw in there. But that's what big battery spec said. But when I wanted to use the mate, I had only, these are the 8 parameters I got to choose. Notice that 8 parameters is not the same number of parameters as here. It's not so much different. This is 10 parameters, okay? And over here are 8 parameters. So there was a mismatch. But that isn't only mismatch. There was also a couple of weird things. This particular entry in the mate, which was the, again, the chart, the parameter I could change in the Outback system, had a unit I did not expect to see, AAC. So what do you guys think AAC stands for? That was my first thing to change. It was started off at 18 AAC, and I thought I would change it to 0, and later I changed it back to 18. What do you guys think that is?
Alternate?
Are you there, Richard?
Yeah, alternate
Is it-
probably
is
one of
it alternate AC?
What'd you say? I'm sorry, who said something?
I was wondering if the first A stood for alternate, but that doesn't make any sense to me to have an alternate AC charger.
Okay. Anyway, as I said earlier, I wrote it down, but I'll tell you, I wrote it over here.
C stand for cell, maybe?
I'm going to talk about paragraph number 2.
Okay.
Okay, in this case, neither Myron nor Kay properly guessed what AAC stood for.
Okay.
We didn't know what it was.
Amperage.
However, I spoke to Jeff Canton, who is unlike Dave, or maybe like Dave, is certified to install these things. It means amperage in AC. Okay,
Input amperage.
input amperage. Very weird because that's not a parameter of the battery, right? The battery list, remember I told you, this is this, what you see here on this page is an exact extraction from the battery spec sheet. This is the battery spec sheet, which has this data, and this is the same data, okay? I just pulled it off the table. Here's the right-hand side. Notice nothing in here talks about the battery amperage, input amperage, okay? Nothing. So what is it there for? But it's important to the inverter. So I didn't know what it was, neither did Kay, and Kay makes batteries. I didn't know what it was. Kay makes batteries and just says it's the amperage of the battery, of the inverter, energy going into the inverter on the AC side. How many amps do you want the inverter to use while you're charging the battery? That's what this question is. And we didn't know it. You would not expect this to be a parameter that changes when we go from one type of battery to another. And maybe it didn't need to change. At first, I changed it to 0 because I was afraid of it. Okay. All right. And then I moved it back to 18. All right. We're going to talk about that shortly. But all the other stuff, this is we talked about before. That's the charging voltage to get it up to 99% charge. And this is the charging voltage to refloat it when it got too low. If it got below 10% state of charge, this was the voltage we found on the graph. Remember? Okay. So this number we found on the graph, this number we found on the graph, and then equalize. What's this equalize thing? So it's apparently when you have a lead acid battery, you've got to spend some time equalizing all the cells so they're the same. But when you go back to the specs of the big battery, equalizes off. It doesn't equalize. So that means we don't need to worry about that one. So what I did with equalize, I set it to 0 hours. As long as I set to 0 hours, it doesn't matter what I put here, right? Because there's no equalize, right? So how long should it charge? I don't know how long it should charge. That's also not a parameter that Big Battery gave. And so this is kind of the middle of the voltages. That's the high end. This is the low end. That's sort of on the middle. And that means it floats. This is where it goes around when it goes in that range, and it's okay and charges a little bit, I guess. I don't know. Anyway, that's what I put in. I sent all these to Big Battery and asked them to tell me it was okay. And when I finally got him on the phone on Friday morning, he said, yeah, those are fine. Okay. However, I still didn't know what to do with AAC. So let's go look what happened with AAC. So here's the story. How we doing on time? Plenty of time. Okay. So to understand this, I didn't know what AAC meant. Jeff told me his input amperage. Now, why is that important? Well, the battery, the inverter is going to use power, and it's going to move that power. It changes to DC and send it to the battery. It may be 100% efficient, but it's certainly close to it. And so we would expect the energy going into the inverter should be close to the energy going into the battery. So I didn't know what to set it, but the guy from Big Battery says, as long as we keep the input amperage to the battery under 100 amps, we're doing fine. Okay. Now, when I think about that, and you all, every day of your life are charging DC batteries because you have cell phones, right? Even if you never had an electric car, and Dave and I both had the pleasure of owning electric cars, we worry about our batteries. The battery is the most important expendable, disposable, fragile part of the car. You don't have the battery, you got nothing. Similarly with your cell phone. So you don't want to charge it too fast. The fact that it can be charged to 100 amps doesn't mean it's good for it to be charged at 100 amps, right? In fact, that's one way to ruin your car battery, and it's one way to ruin your cell phone battery. So if they say we can go 100 amps, I feel pretty good if it's considerably lower. But what to set it to? So I didn't know what to set it to. So this was the case, even though the actual limits in DC charges was not published in the charging parameter set. I remember over here again is the charging parameter set. It makes no comment about how fast you should charge it. Okay. All right. So I inadvertently did a charging test. I did a good battery charging test. Now that wasn't a big battery charging test. It was a good battery charging test. In case you have your adverbs mix up with your adjectives. Okay. This is not a good battery charging test. It's a good battery charging test. Okay. All right. All right. This AM, by changing the first parameter listed in the mate input process, namely I changed charger A00 AC back to 18 AAC. Okay. Now I did this partly because Jeff told me it's input amperage, and that's not an unreasonable amount of amps. It's way lower than 100. So I took a shot at it. And as I did this, I also had another device running on my phone. Now, on my phone, let me quickly get to that. I can do that with this. I have to go back to another page. Hopefully I can get back there quickly. But there is a app you can put on your phone called the battery. It's called Battery Monitor BL. I don't know what BL stands for. But anyway, and I put it on my phone and it talks to my battery with Bluetooth. And when I do that, I can see information about how charged my battery is. So if I go over here, I raise the resolution a little bit higher so you can see what this looks like. And you can see with this, I can actually see what's going on to my battery. It'll tell me how many volts I have. It'll tell me how much power I have, because this voltage, remember that state of charge is directly associated with the voltage. So it can know its state of charge. And in the current condition, before I connected it to the inverter, it was not receiving or losing any current. But this is the kind of screen that I could get with the battery software running on my phone. So I had the battery software running on my phone, and I was looking at this, and I said, okay, what do I do? So I said, I turned it on and I used the app I just described, namely Battery Monitor BL. I used the Bluetooth, and the app showed me at the start of the test, my battery had just about the same state of charge as when I received it, namely 89%. How do I know that? Because I had run this software earlier before I started trying to set the parameters. Rafter changed the spec from 0 to 18 volts AC, of 18 amps AC. The inverter's fan started and had never started in the last many months because I couldn't charge anything. And if it started, it means it was doing something and it needed to cool off. So it was charging. And here it was. And the state of charge increased to 98% before I opened the DC circuit breaker. And that charging happened in about 10 minutes, which means the state of charge increased at about 1% a minute, which is the same speed of charge I use in my cell phone. I don't know if you notice how fast your cell phone charges, but I do, about 1% a minute. And I noticed that the battery monitor was telling me how fast it was charging. Remind you over here that when I go to this thing and I use that software, it will tell me what's happening with the charging right here. See, this says it's charged, that's not charging at all. But when I was actually running it with the inverter on and actually charging, I was seeing 36.5 amps. And I said, well, that's not 100 amps. I shouldn't be upset, but at least I know it's okay. So I wondered if I could predict the 35 amps DC from the 18 amps AC. Now I'm going to stop. Okay, anyone who's taken high school physics should be able to answer this question. Okay? You can read on if you want. There's the answer. Okay? Is DC amps AC determined by 18, I'm sorry, DC amps DC determined by 18 amps AC? Come on. That's a high school physics question.
I didn't have physics high school.
What'd you say?
I didn't have physics in high school.
Okay, that's Dave's excuse. What about yours, Brendan? You got a PhD in engineering? Come on.
Yeah, I'm really good at studying for the exam.
How
My
about you, Richard?
teacher's name was Heskew.
How
Oh,
about you, Richard? Come on, this is not tough.
I just asked Google.
Okay, look, forget about that. Okay, look, you've got an inverter. It's changing AC to DC. Let's suppose it's 100% efficient, and it's probably close to that. And it'll ignore the difference. How many amps will you get DC if you use 18 amps AC? Now remember, it depends on the circumstances.
Two.
What's the circumstances? Come on, think with me. What is the amperage? What's the voltage that the inverter is seeing all the time? Input voltage. It's a 110. It's seeing 110 volts, right?
Yeah.
Yeah, of course.
And what is the voltage the battery is seeing all the time? Caused by the inverter. We were just talking about it. Remember, the upper end of the range was 57 volts, right? Remind you, look over here. The upper end of the range is 57 volts. The bottom end of the range is 50 volts, right?
Yeah.
Okay.
So what's the average voltage in that range?
Yeah, 53.5, somewhere in
Right.
that 53.5.
Very close to 55 volts. I'm skipping because I want to make it easy.
About half. Yeah, 2 to 1.
Right.
Mm,
So
wow.
the voltage going out is half the voltage going in. Okay? So what would the amperage be? Assume 100% efficient inverter. If the voltage is half going out as the voltage coming in, okay, what would the amperage be?
Well, you just
Okay, here's the key question. What is a watt? A watt is the product of which two variables? Volts times amps, right?
Volts times amps equals watts, yeah.
Exactly. Volts times amps equals watts. And it doesn't matter whether it's AC or DC, there is an effect where because you're out of phase, you don't lose some energy, but that's negligible compared to what we're talking about. If volt times amps equals watts, and it doesn't matter if it's AC or DC, then the amount of energy going in would be, let's say the input energy would be in, assuming we're at 18, I'm jumping too fast, let's say. We're 18 amps going in, okay, right? 18 amps going in at 110 volts. How many watts is that? 18 times 110 is about 2,000 watts, right?
Sure. Yeah, if we round
Right?
18 to
Okay.
20, might as well round it. Yeah.
It's about 2,000 watts, right? Am I wrong or not?
Yeah.
Okay,
Calculator.
come on, you can do this. You remember you did it before you were
Well, I mean, it isn't 2000. Isn't it like 1,800 something?
Yeah.
well, you forgot about that's 110 volts,
Oh, 110 volts. Okay.
right? So it's pretty close to 2,000, right?
Oh, you know what? You're right. Yeah, that'd be like 1980.
Yeah, right. It's very close to
Because 8
2,000.
times 10 is 80.
Okay. For the purpose of this discussion, we
Yeah.
aren't dotting our i's and crossing our t's and trying to get a ballpark idea, right?
Yeah.
So it's about 2,000 watts or 2 kilowatts is the input power. Okay, so what's the output power? Well, it's going to be 36 amps times 55 volts. And that is what? 36 times 55. Now, you may not be able to do that in your head, but an answer again is around 2,000 watts. Okay? That sound right? And it has to be because if one is half as big as the other one is twice as big as the other. If the amperage is half as high, and the voltage, if the amperage is if the voltage is half as high, then the amperage has to be twice as high to get the same number of power. Okay, so basically what I'm saying is because the ratio of voltage is 2 to 1, the ratio of amperage is 1 to 2. Do you have the same watts? Get it?
Yeah, I'd say instead of high school, that's more like elementary, Watson.
Everybody following me? Okay. This
Well,
is
wait, so I have a question about the transform AC to DC. So, the method of it doesn't require a transformer and
yes.
rectification.
Now, if you want to build your own inverter, we can talk about it. I don't have enough physics degrees or electrical engineering degrees, but I know the basic idea. Okay, in order to change AC to DC, you have to have a circuit which always pumps out DC, and then you have to clean it up so that you get a sine wave. But you can do that with a square wave rectifier. So if you don't mind having a bumpy signal, just every time it goes into the negative, it's sent in the same direction. So you get DC pulsing coming out.
Yeah, so is it 2 to 1 because of the positive half cycle when there's two diodes that conduct?
It's 2 to 1 because of the ratio of the voltages. If the voltages is half as high, then okay, and to have the same amount of watts, you need half as many amps if you use twice as many volts. Okay, it's straightforward. Watts equals volts times amps, independent of whether it's AC or DC. Okay, so if you want to build, we want to have a class on building inverters. That's next week. Okay. Anyway, so therefore the DC amperage should double to have the same watts on both ends, right? Okay, it's right here. And that's why 18 AAC corresponds to 36 amps DC, or approximately, right? Twice, right? Okay. So I then considered if this setting were too high for optimal battery protection, I conceded that 36 amps is a lot lower than 100. I shouldn't worry. That doesn't mean that I shouldn't worry ever, because I always charge my electric vehicle with level 1 charger, which is like maximum for my car, 3 kilowatts. I have my car has a 20 kilowatt hour battery charging at 3 kilowatts. If I want to charge it to a completely empty battery, I can only do 3 kilowatts an hour or 3 kilowatt hours an hour. So to do 3 goes into 20, roughly 8 times, it'd take me 8 hours to charge my battery. But if I decided that I wanted a level 2 charger, which will assume is 2 or 3 times the watts, I could charge in 1/2 or 1/3 the time. But when I charge at higher amperage, I could be damaging the battery. So I think that may be why my Leaf has 80% of its original battery life, even though most Leafs are dead and gone to heaven a decade ago. Okay, so at least I know this is a feasible answer. And so when I actually look at what parameters I chose, which is at the end of the email, it's right here. I chose to put the amperage back to 18. And I chose to put the set point from 50.8 volts to 51.2 volts. So why did I use 51.2 volts? Anyone here who didn't fall asleep in the meeting would know the answer. What's the answer? Going back to this graph, okay? No, I'm sorry, not that one. Yeah, this one, but it's in this one here, right here. Okay. Okay. 50.8 volts gets us to in the 10% state of charge, but 51.8 volts gets into 20% state of charge. Okay. So I use a smaller range in the cycle to have more cycles of battery life. So by using the higher low end voltage right here, from going to 50.8 to 51.2, this is to get me to 10% state of charge before I recharge. And that gives me 20% state of charge before I recharge. And that gives me more life. Okay, so that's a general answer to the question. We've covered the topic. We have 15 minutes left. I'd like someone else to suggest what they'd like to hear about. And it's got to be really interesting to wake up Dave, who's sleeping over there.
So how much did this set you back?
Yeah, I was wondering about it too.
All right, so it turns out that it was advertised for around, big battery, for around 1,800 by the time it paid for tax and shipping. It cost slightly over 2,000. Now, in retrospect, this battery array here, I purchased for $3,000 in 2010. Now it was a 20 kilowatt hour battery. And so it's really more expensive than this because of the value of the dollar, but less if you ignore the price of the dollar drop. But these only have 700 cycles. This has 5,000 to 7,000 cycles.
Yeah.
And
The
I can
inverter.
get more cycles if I use a higher end of the recharging. If I go to 20% state of charge, I can get more cycles. I get in this range. If I stay 20% state of charge, I stay always in the green. If I go down to 10% state of charge, I go into the yellow as well. So now, if you're paying attention, what should I set it for to give my wife more resilience when the light goes out when the hurricane hits? Should I set it on 20% state of charge or 10% state of charge when it recharges? Or ultimately, another way of asking the question, if this is your only source of energy and you're going to lose all your food in your refrigerator if you can't keep it running, do you want your battery to stop at 20% state of charge or keep going down when it goes down to 10?
Guessing stop.
What'd you say?
Stop.
What'd you say?
Stop at 20.
Well, if you stop at 20, your battery lasts longer, but your food doesn't.
Well, yeah, there's a trade-off of the.
That's right. So here's the thing.
Although, yeah, your question was about, your partner being angry or something. If you, like, which one would you choose to not make them?
Well, here's the thing, if I were in New Orleans, I would definitely leave it at 20%. But I plan on being out of town for 10 days.
Oh,
Now,
yeah.
remember, I can't expect my wife to reset it from 10% to 20% or from 20% to 10%. She probably can't handle it. Okay. So I want the food to last as long as possible. So I guess what I should do is leave it on, to get the extra 10% of the battery life so that I can keep the food growing a little longer. Now, that doesn't mean she's dead in the water when the light goes out. Food, if she keeps the refrigerator closed, it'll help. Or we could turn the battery on and off and restart the thing, but we also have a generator outside. And this is very interesting, I think, about generators. Generators make the same amount of power. I think the one I have outside is a 7 kilowatt generator. And it makes the same amount of power all the time. So you want to pair your battery inverter. So remember, we were talking about running the inverter at 2 kilowatts. Remember, we calculated that at 18 amps, the inverter was using 2 kilowatts, right? So if you had a gasoline generator that was a 7 kilowatt output generator, and a lot of them are, you would be generating 2.5 times more. You'd be doing quite a bit more power than you could use. That's good and bad. So let's figure out why that's good and bad. Well, you turn on the generator for what reason? Well, because you want to do something that you couldn't do before. Well, first you want to get your food cold. That's important. But you have all this extra power. You can't use the power right away because your refrigerator, my refrigerator uses 2 kilowatt hours a day. So if I turn everything off in my house, and I tell Sharon, as soon as if there are the hurricanes coming and the power goes out, immediately unplug everything in the house, even the internet and all the laptops and everything, unplug everything except for the refrigerator. And then now you can run 2 days. Okay. And 2 days could be all you need for most power outages. I'll tell you, I've lived through at least 10 hurricanes in this house, and all but Katrina, all I need is 1 day of power. So if unplug everything, leave the refrigerator going, and you're done. However, 2 days is a lot of time. In 2 days, you can walk around the neighborhood and find someone with a generator on, whether it's a little bitty generator or a big generator, and you run a power cord to them, which they'll do to help you keep a thing. And all of a sudden, not only have you solved your problem, but now you can recharge your battery because you'll be getting more power than your battery can consume. Okay. All right. So, 18 amps is AC is not a challenge for a number 10 wire. If you have a 100-foot extension cord, it'll probably be a number 10 wire, and you could easily run 18 amps through that. If you've done any wiring in your house, you know the number 10 wires or even number 12 wires can do 18 amps. So therefore, you could get 18 amps into your house and recharge your battery. Okay, you don't need any more than that. And if you have someone with a 7 kilowatt generator, they probably got it sized that big for their air conditioner, but their air conditioner only runs 20 minutes an hour. So the other 40 minutes, it's outputting energy it has no use for, and it's delighted to give that power to you without any imposition on you. Okay, so on the person with the battery, the generator. So what happens is the battery becomes a buffer to absorb all excess electricity that's being generated in your neighborhood. Even the guy who has an inverter big enough to run his air conditioner cannot use the energy the generator is making. Only at best 1/3 of the time, all that extra energy is being wasted. May as well give it to your neighbor. And then if your neighbor charges a battery and he's still connected to you, his battery will protect your home. So it becomes very synergistic and symbiotic. Okay. So resilience should go both ways. It should help the person who helped you and vice versa. So the battery is very valuable, but it has to be able to do deep cycles. My old battery was completely dead. 20 kilowatt hours of dead lead acid batteries is worth nothing compared to 5 kilowatt hours of a lithium ion. But if you really compare the amount of energy and throughput this one lithium ion battery, although it has less energy per cycle, it has so many cycles. So if we did a calculation and we ignore the fact that it's 80, not 90%, or 90%, not 100%, you just assume it's 100% per cycle. We have 5 kilowatt hours per cycle. We have 5,000 cycles, and we multiply those two together, and that's something like 5 times 5 is 25. 25 what? 25 megawatt hours or something like that you would get out of this thing over the life of the battery, but it would be like 1/10 of that in the lead acid battery because it only can do 700 cycles, and this lead acid battery can only go 50% of its total capacity. So it's a tremendous difference in the amount of energy. So although I spent 2/3 as much money in dollars, ignoring the real value of the dollar, I got 5 times or 10 times as much usable like energy I can store and take out of it. So I think that's an important lesson about this story. So
Yeah.
I know Dave isn't going to say anything because he's sleeping. What do you think of this discussion, Richard?
It was interesting. The inverter, is that the inverter part of the 2,000 in the shipping cost? And the communicator between the battery and the inverter.
Okay, so I mean, you're asking me a question about what did I get for what? Okay, so we go back to this. Here's the picture. Okay, all right.
Yeah.
This is the inverter I purchased
Yes.
in 2010 for about $1,800.
Okay.
There is a transformer in here that changes 110 volts to 220 volts, so I can send that to my house. And this is the switch panel that sends electricity to our house. All this was
Okay.
purchased in 2010, as well as these in batteries. All this equipment together cost me $5,000. That was an 80% tax credit, so ultimately cost me $1,000. Now, 15 years later, these batteries are dead. The inverter works fine, but I've got no batteries. So I spent $2,000 for this battery. And although it has a much more shallow total amount of energy per cycle, but it has so many more cycles, it's probably like 3 or 4 times as much energy over its life as these batteries here. Okay. So I have to be more careful when the grid goes down and here I have to unplug everything but the refrigerator. Whereas with these batteries, because they have a deeper thing per cycle, I have like 4 or 5 hours to unplug everything. I don't have to drop everything and do it. But this will get me through the other part of the whole purpose of this meeting. Remember, it has to be supporting the notion of the goal of this organization, which is ProRate Energy. This inverter will cycle every day for a decade without losing its viability. And that's what I wanted to do with the time of use rate. So does that answer your question, Richard?
Yeah, and so the old batteries are still in place for about 5 hours of operation. Is that what you're suggesting?
No, these old batteries are completely dead.
They're gone. They're off.
They're just, all they do is holding up a table right now.
Yeah, my ex-brother-in-law is a electrician, a master electrician. So technically, if I was heading in this direction, and this possibly is coming up, then we'll go from there. The issue is finding solar, finding what's going to happen to solar as we progress into the year and into the Texas government kind of downplaying anything in regards to green energy.
Yeah, well, they may
See what's going to happen.
They heavily depend on it in Texas.
Of course they do. Of course they do.
Heavily. Anyway, I hope you guys found this interesting. It was a real important excursion for me. I finally got it set up right. And I think when the power outage comes, this automatic transfer switch will immediately transfer all the power. Instead of coming from the wall, which is the backside of my service disconnect for the house, that's what this is. That's why these big wires go through the wall. When these powers when these wires have no power, this automatic transfer switch will notice it and provide the energy coming from the battery, and I'll be able to run my house for two days if it's just the refrigerator, and considerably less if I use more, but at least I have some way to keep my wife going. And hopefully if she has 2 days of power, she can find something else to back it up.
You bet.
There actually is a gas-fired generator, gasoline generator, right next to this wall right here. And my son's gonna be in town and he can plug it in and then we can keep the battery going.
Got you.
Okay. All right, so good night, everybody. Hope you found it interesting. Okay,
Thank
Thank
you.
okay, good night.
Yeah.